I'm going to talk about Hyperledger Fabric and how we're going to use Vault. So I think everyone here has encountered the situation when you have an idea and then you think up a POC, you build it out, you start the CA, get the certificates ready, and get your network up, and then you test it and everything's working fine. And then you decide, okay, let's maybe scale up and like let's run it on an orchestrator or some tool like that. And then we spend a week to figure out how to do that, and then we do it, and then suddenly we realize that our certs in the wrong container or something else, or when we turn on TLS and some certs are again, something happens and there's no connection between them. So that's usually the case with me, and I think most of us. So yeah, so here what I'm going to show is how do we move away from that model, as in creating certs, putting them in like Kubernetes secrets or storing them in a zip file and getting them down for Nomad and then into the containers, and how to like dynamically generate certificates for the peers and auditors of the Hyperledger Fabric network, and have a dynamic network that can scale well and is easier to manage essentially. Okay. Yeah. So yeah, so on the agenda today, I'll give you a brief overview of what a blockchain is, and yeah, and I'm only going to focus on the parts that are required in the Vault PKI engine, the setup of it for running a Hyperledger Fabric network and setting that up. There are very good talks that explain how to set up a PKI engine. I'm just going to look at how do we configure it for Hyperledger Fabric. So, and I'm just going to go a brief overview for what a blockchain is for some people who might not know. And then we will dive into what's the PKI engine, a brief overview again, and then to the demo and the certs, how are they structured, and how do we like have them configured for Fabric and stuff like that. And then we'll see how Vault and Consul-template play a role in helping us get a dynamic and scalable deployment. And then how do we translate from our example here, which will be with Docker Compose and Consul-template and Vault, and how do we like translate it to maybe Nomad or Kubernetes and how that is done. Okay. Yeah. So yeah, usually in any conversation, when someone asks me this question or in some situation like this, the person asking the question and me at the same time will be like, okay, how do I do this? How do I explain what blockchain is? And I've probably taken 4-hour videos for me to understand what that meant as well. So, or it's usually the other way. The other thing that comes up is, oh, Bitcoin or crypto. Oh, I know what blockchain is. So usually that's where the two cases that happen when blockchain is brought up. And yeah, so Bitcoin is the original blockchain. It's the first public blockchain. It is the OG in a sense. And we aren't going to talk about public blockchains. We're going to talk about private blockchains. That is what Hyperledger Fabric is. And yeah, now to give you a brief about what a blockchain is, it's a distributed and immutable ledger where all the participants make sure to maintain the state of the ledger or the list of transactions in the ledger. So everyone in the network works together to maintain that state. So essentially all the distributed participants work together to maintain that the ledger is in this state and everyone here agrees upon it. And the network participants usually have a public and private key to prove their identity. And that's how it works in most public blockchains, including Bitcoin or even Ethereum. So then now the question is, what is Hyperledger Fabric? That is a private blockchain. So the only difference between that and say Bitcoin and other public blockchains is membership. So in a public blockchain, everyone is free to come join and take part essentially. But with Hyperledger Fabric, it's a more, gated approach. Only certain entities are allowed to take part, and that is done using PKI. So each organization has a PKI setup that influences who can take part in the network and what are roles they can do and all of that stuff. So yeah, then I think the next question in everyone's mind is, what is PKI, right? PKI stands for Public Key Infrastructure. It is a set of technologies that are used to set up certificates and other stuff. And those four parts are the certificate authority, the entity that issues certificates, and then there is a digital certificate that is given to the entity, and that has some extra metadata and a public key about that certificate and the entity. And then there is the certificate revocation list, that is essentially a list of all bad certificates or expired certificates, to make sure that if anyone is trying to use those certificates, they know that it's no longer valid. So essentially, these are like the four segments that are used to maintain membership for each organization in Hyperledger Fabric. So they use the CA and the certificates more of into the configuration of Hyperledger Fabric to define the rules. Okay, then it comes to Vault PK engine. So Vault, as a brief, is a secret management tool. You can store static secrets or generate dynamic ones. They have a wide variety of engines, that's what they call them, to generate like secrets. And we're going to look at the Vault PKI engine for our use case right now. And so what we'll be doing is the entire setup, right? Those four parts: the certificate authority, the certificates, the certificate revocation list, and the public and private key. We're going to configure all of that for our use case in Hyperledger Fabric, and we will see how to do that. Okay, I think it's time for the demo. So let's run some code and look at how we do this. So I will just start off the network and then generate the certificates, and then we'll start exploring about, okay, how did this happen and how do we make this happen and what is required for Hyperledger Fabric. So I'm just going to start a Docker container with Vault. And then I'm going to just like, yeah, let's just open the UI for Vault. And as you can see, these are the two default secret engines that are there when you run it in dev mode. And let me just show you all what I'm running. So it's essentially a Docker container. So in Docker Compose, and I can just, it's just this simple file. And I'm running it in dev mode, and I'm passing these two parameters. That's it. So yeah, so now this is the base Vault running. Now let's configure our PKI engines for our demo right now. So Vault has an API that you can hit to configure all of these. So that's what we're going to do right now. And then we look at what are the actual request bodies that we're sending to configure these a little later. And that should be it. Yeah. As you can see, there are four new entities. So this is so there are two kinds of CAs that are being set up, one for membership and one for TLS. So we have two organizations here, an orderer organization for the orderers. And I'll explain what an orderer is and a peer is a little more later. They're just parts of Hyperledger Fabric. And yeah, we have another organization for membership and for TLS. Yeah, so now let's just generate the certs from this endpoint that is there on Vault. So yeah, let's go through the script that I actually ran here to see what happened here. Yeah, so I essentially ran this makefile and that just ran the script. It's just easier for me to type the commands, so that's what I did. So yeah, there are two functions in this. One is called MSP and the other one is called roles. So yeah, Hyperledger Fabric has four types of entities. They are clients, peer, admin, and orderer. So Orderers are usually the entities that take care of managing the blocks and making sure that there's the right order of them. And peers are the entities that actually store the blockchain and make sure that the data integrity is there and does all the checks. And admins and clients are different user roles that can take part in the network. And yeah, so the MSP is doing the high level organization configuration. It's just technically, let me just show you the folder structure. I think that'll be clear. So yeah, so for the order org, there's this MSP folder that has the CA certificates and the TLS CA certificate and this config.yaml file. So that config.yaml file essentially is this. And all it's doing is sort of informing Hyperledger Fabric that anything that has a certificate authority that is similar to this certificate authority and has an organizational unit with value client is a client to the Hyperledger Fabric network. And similarly for peer, admin, and orderer. So here we're using the same CA for all these organizational units, but you could change it up based on what your need is. And yeah, so this is the configuration that is going to be passed to Hyperledger Fabric. Now let's look at how we generated this, right? So here we have some console templates that are generated using my shell script for the different roles and the organizations essentially. And let's just open up one of them. Essentially, this is talking to this endpoint on Vault to generate these certificates for us. And it's passing in some values like what's the common name, the time to live, and some other alt names and IP sans for our use. And similarly, we have the same thing for TLS as well. And it's just that I have named it as organization name and CA and organization name and TLS-CA for our use case right now to make it easier to understand. And look at that. So yeah, so this is for the order org, and similarly, the certs are there for the peer org. The same structure is essentially there, but here we have two more entities. We have an admin and a peer. Now let's actually look at the certificates and what was actually generated, right? We'll just look at the peer certificate. And I'm using OpenSSL to look inside the certificate and get in a human readable form. Yeah. So this is what is generated. And as you can see, this portion, hope it's clear, is the organizational unit. And we are using an elliptical curve algorithm for the cryptography. And then you can also see that this one other field here. That is the key usage and digital signature. Essentially, this is telling that the certificate can be used to prove the identity of the holder of the certificate. And then we're telling it's a peer to the Fabric network. So when we do apply rules in the Fabric network, it reads in this value and says, okay, you're allowed to do this or not. And let's just look at the TLS certificate and see what the difference is. Yeah, essentially everything is the same except for this segment. We add extra key usages, and we also add this TLS web server authentication and client server authentication for the TLS portion of it. And everything else is pretty much the same. We're using the same algorithm and stuff in our example here. So yeah, now actually let's look at what was the request that actually formed these setup in Vault, the PKI engine and these roles. Yeah, and the Vault PK engine has this concept of roles. Essentially, they're like templates with like pre-filled values for that we can use to generate certificates and stuff like that. Right? It becomes very useful when we're generating certificates and we only need to alter certain stuff, and when everything else is the same. So we'll look at that example right now. So first, let me go through like what happens first. We create the PKI engine. We technically pass this value to this endpoint. It's sysmount slash the name of the path that we want to create, and then what do you say? And some extra config like was a max TTL. You want seal rapid and certain other parameters. And similarly, we configure the CA. So here what we're saying is we want a max TTL of this much, and we want to use the elliptical curve algorithm because that's the default algorithm used by Hyperledger Fabric, and the default bit size is around 256. So that's what I'm setting. It just seems a little complicated, but this is the same collection that was run by me in the starting to configure Vault. And yeah, now we can come to the roles. So this is the endpoint that is used to configure the roles for us. So the main thing that we have to keep in mind is, just a second, the wrong one I opened. Yeah, is this payload that is being sent. So here, these are the three things that have to be kept in mind. So the key type, as in the algorithm for the cryptography, then the size, we're setting it as 256, and then the key usage. These are the main factors that are needed for setting up this network. And then these flags are turned off because this is not required for TLS. And the only difference is when I just open up the, okay, it on the side. The only difference is that the server and client flag are enabled for TLS. Essentially, this allows for TLS communication and these extra two values in the key usage for TLS. Hope that makes like gives a little better picture of what we're configuring and what we're generating as in the certificates for the Hyperledger Fabric network. Now, yeah, now let's use them and see if they work, right? So now what we're going to do is like generate the configuration that the Hyperledger Fabric network is going to understand from these certificates. So our folder structure that we created is going to be used to generate this configuration and stuff. And technically, we're just creating something called a Genesis block, the starting block of the blockchain, which has the configuration of all the organizations and stuff. That is this. I'm not going to go into the details of this because that we don't have time to dive into that. And then we're going to look, and then we're just telling we're going to start this particular channel in Hyperledger Fabric, and then certain other configurations for the network. And then let's bring the network up. Yeah. Now the network has started, but it is not connected together, and the blockchain network hasn't been formed. So let's just look at the peer and see what's happening inside there. Yeah, as you can see, it's started, but there are no active channels, as in there is no private blockchain running. So then let's get the network connected and running. Yeah, okay. Before that, let me just show you what kind of network we're actually running, right? So the network we are running it contains a single orderer, a single peer, and a CLI. Essentially, this is an admin that is used to perform tasks on the network, like the task we're going to perform now of actually making the peer join the network and be part of it and all of that. Essentially, the CLI is used for that purposes, and then the peer is there to actually hold the blockchain and the data and stuff like that. Oh, sorry, this done. Now let's just install the channel. Yeah, and for those who've not seen this before, just technically the CLI communicating to the peer and orderer and setting up this network for us. And let's look at the logs of the peer and see what's different, right? Yeah. So the most important thing, so previously it was at here, no active channels passed. Then you can see creating the ledger with Genesis block, and these are certain other configurations and other input details that it's telling us. But essentially, it is now part of the network. So now we know that the certificates we generated works and is a part of this network, right? So yeah. So now we've seen how to like basically set up a PK engine and how we can use those certificates to start a network, and how Vault can be used for like dynamically setting up PKIs for different organizations, especially in Hyperledger Fabric. Each organization needs a PKI setup, and then it will be dynamic, right? Based on your channel requirements, you need to add a new organization or something else, or you may need to add more peers. And for all of that, Vault and Consul-template together can provide this dynamic way of generating certificates and reissuing them, and not having a TTL of maybe like 10 years, right? Or maybe a shorter TTL for better security and other purposes. So now let's look at the transition, right? Now this is running on a local network, and now we want to run it on an orchestrator, say Nomad. So let's look at what actual configuration difference is there in an actual Nomad file that is required. Actually just this one block. Essentially you'll need three blocks, but essentially it's just a copy paste of these. But yeah, essentially just this one template stanza in a Nomad job file will generate certificates and put it inside that container for us, and then manage the life cycling of the certificates. So if you provide a TTL of maybe a day, what happens is at the end of the day, the certificate is renewed by Nomad, and then the container is restarted using this template, right? So it is completely no longer in our hands, is managed by Nomad. We don't have to worry about, okay, when is that certificate going to expire? Is it today, tomorrow? What is going to happen? And try to be a Jedi, like, okay, is it going to be like tomorrow, today? No, it's going to be today. So no tensions anymore. Like we can let Nomad do this with Vault. And similarly, you can do this on Kubernetes as well. Once you install Vault inside Kubernetes, you can provide a similar template into the YAML file, and then it will manage that for us. Yeah. So yeah, so as you could see, Vault and Console template help us set up these dynamic PKIs and certificate issuance and reissuance of certificates for us, because that's the main problem in setting up networks in Hyperledger Fabric, right? We spend so much of time actually setting up networks and maintaining them rather than building APIs and other chain codes and other stuff that actually bring more value to the network, like use the network actually, right? So this makes setting up the network way more easier and scalable as well for multiple organizations, multiple peers. Like if you wanted, you could just set up 100 different peers, right? You just needed to write those 100 job files that you're going to do anyway for running the containers, and then you just add, what do you say, that template stanza, and then it works. And yeah, so I hope this was useful to you guys. And yeah, one more thing is you can look at these resources. This is an introduction to Fabric if you need it, and then this is a detailed PK documentation of how it is being used in Hyperledger Fabric. You guys can go through this. It is very detailed and it explains it very, very well. And then you can also go through this build your own CA that is there in the Learn platform of HashiCorp. It is very nice. And you can play around in setting up your own Vault CA. And then you can look at the collection that I used to run. It is there in the So you can use this, look at this collection on Postman and see what are the differences are and how we set up the use for our use case in Hyperledger Fabric for your use later on. And then you could like build up your own networks and play around with it. And that's it. I'm Sachin Gowda. I'm a blockchain developer at NGP WebSmart, and you can find me at Twitter at this handle. So if you have any questions or anything like that, please hit me up, and I hopefully can clarify those doubts for you. Thank you.